Good evening, everyone. It is my great honor and privilege to welcome you all to the 6-day IICTE ATAL sponsored faculty development program of the theme Sustainable Urban Growth, the intersection of smart cities and mobility, organized by the Department of Civil Engineering, University College of Engineering, Ramanathapuram. First and foremost, I extend my deepest gratitude to AICTE at TAL for the generous sponsorship and continued commitment to fostering academic excellence and professional development. Their support has been invaluable in making this program a reality in advancing our collective efforts to addressing pressing issues like sustainable urban growth and smart mobility. I would also like to acknowledge the guidance and support of our esteemed Chief Patron, the Honorable Chairperson and members of Convener Committee of Anna University, Chennai, for their unwavering support and encouragement in making this program a reality. Your visionary leadership and commitment to academic excellence continue to inspire us. A special thanks to our patron, Dr. J. Prakash, Registrar of Anna University, Chennai, for their guidance and the constant motivation which have been instrumental in shaping this program. I would also like to acknowledge the contributions of our chair, Dr. P. Hariharan, Director of Anna University, Chennai, and Co-Director, Dr. T. Uday Kumar, Dean, UCER, Ramanathapuram, for the valuable insights and supports in curating a program of this magnitude. A heartfelt appreciation goes to our coordinator, Dr. G. Lavanya, Assistant Professor and HOD in Civil Engineering Department, UCER, Ramanathapuram, and Coordinator, Dr. J. Vijay Assistant Professor, Civil Engineering Department, UCER, Ramanathapuram, whose dedication and hard work and meticulous planning have ensured the smooth execution of this initiative. This faculty development program has been carefully designed and to learning, sharing, and enhancing the skills of educators in the field of civil engineering. Over the course of this program, we will have the opportunity to interact with esteemed experts, delve into the latest advancements, and explore innovative teaching and research methodologies. I am confident that this program will provide you to be a significant milestone in enriching our academic and professional endeavors. On behalf of the Department of Civil Engineering, I extend my warmest wishes and a successful and engagement program. Let us make this opportunity the most of the opportunity to learn, collaborate, and grow together. Thank you, and once again, warm welcome to all.
I request the participants to switch on the video. Thank you, everyone. Thank you, everyone. You can off your camera. Let's start the first session by inviting Mrs. Sujatha.
It's my privilege to welcome Ms. Sujatha Vijayaraghavan, a distinguished data scientist and expert in leveraging data-driven insights for innovation and growth. Her vast experience and expertise will undoubtedly inspire and have enlightened us. She is a data scientist with expertise in causal inference, machine learning, and advanced analytics, delivering impactful solutions across the telecom, urban policy, and resource management. At UST Global, she led major telecom analytics initiatives, designed a health score metric using complex spectrum data to assess spectrum efficiency and identity site health, and developed LLM-based applications and reducing customer attrition by 15%. Sujatha has applied tree-based models and deep learning techniques in her work, leveraging Python or AWS and GIS for scalable analytics. Additionally, her smart city research has contributed to significant improvements. She's also proficient in visualizing and presenting business solutions through interactive dashboards using Power BI, providing clear insights for decision making. Please, ma'am, you may start.
Thank you, Harish, for your kind introduction. I'll just share my screen. Please let me know if it's visible. Am I audible? Lavanya, ma'am?
You're audible.
Ma'am, you can proceed, ma'am. Sujatha, ma'am, you can proceed.
Okay, yeah. Okay. Good evening, everyone. I'm Sujatha Vijayaraghavan, a lead data scientist from UST Global. And I want to thank AICTE for giving me this opportunity. I also want to thank the dean, then the coordinator, Dr. Lavanya and Vijayaraghavan, for giving me this opportunity. It's truly an honor to be here and to have this opportunity to share the insights on a topic that's both kind of fascinating and transformative, demystifying data science, machine learning, and AI. Okay, so before we dive in, I would like to set the stage for what we will be covering today. Whether you are new to these fields or already exploring them, the goal of this session is to simplify these complex concepts. Okay, so highlight their real world applications and inspire you to think about how they can be leveraged in your respective domains. For example, if you're from civil engineering, how to use that data science and machine learning in your field. Let's make this an engaging and insightful journey together. Please have engagement, and you can ask questions. You can stop me whenever you need. I'll take you into the world of data science, artificial intelligence, and machine learning. These terms might sound complex, right? But our goal is to break them down into simple concepts that anyone can grasp. So if you have ever wondered how Netflix suggests your next movie, do you have any idea? Or how your phone recognizes your face, or how self-driving cars navigate through the traffic? You can let me know in the chat, right? Okay, by this end of the session, you will walk away with a solid grasp of these basics, and hopefully you'll be excited to explore these fields further. So without further ado, let's begin our journey into the world of data science. So what is data science? Before we dive in, let me ask you all a question, like what comes to your mind when you hear the term data science? Is it numbers, or is it algorithms or predictions? Please feel free to share your thoughts. You can put them in the chat. What is data science? The group of data being stored. Okay. So, any other points? Okay. So data science is nothing but data science is like being a detective, okay, where the clues are hidden in raw data. It's a process that combines, right, collection of data and analysis. Exactly, those are great points. Like, so it is kind of whether it's unstructured or structured data, we have to get meaningful insights and knowledge from those data, right? It's a process of that combines statistics, programming, and domain expertise to extract patterns, predict outcomes, and even automate the process, right? You have some data and you have to extract patterns out of that, predict the outcome from that, etc. So that is called data science. Think of it as a connecting the dots between raw information and actionable insights that drive decision making. Throughout this presentation, we'll explore how this process unfolds and how it relates to machine learning and AI. Okay. So this is a simple diagram representing the data science process. We have data collection, then data cleaning, then data analysis, and then from there we get the insights. Okay, with those Lego pieces, we don't have any insight. But after you collect the data, you clean the data, sort it out, filter it out, and then you analyze that. And then you finally make a story out of that, explain it, and then make it actionable. It should be useful, right? So this is what this data science. So the main process is data collection, cleaning, analysis, and then insights. So this is like a picture which explains what is data science, what is artificial intelligence, machine learning, and data analytics and analysis. Okay, this visual which you see on the screen beautifully captures the evolution and also the various branches of AI, ML, data science over the decades, right? On the left, we begin with a broader concept of artificial intelligence, which we always hear right now, which encompasses all forms of machine intelligence. Okay, any type of machine intelligence comes under this group, artificial intelligence. This includes everything from simply automated tasks like smart email categorization to complex systems like Amazon's purchase prediction algorithms, right? Your Amazon, it predicts your purchase algorithm. It has an algorithm. So all those complex systems are designed under this. As we move to the right, the focus narrows down to machine learning, right? This is where computers learn from the data. When a computer learns from the data to make decisions without being like explicitly programmed for each task, you don't, if there is an if else condition, that's a rule based thing. But if the computer learns from the data and makes its own decisions, then it's machine learning. It's called machine learning. Okay, the machine learns something from the data. Examples include like Google Maps predicting the traffic speeds, Netflix recommending videos based on your watching history. So it takes your data, historical data, and it predicts, right? So deeper in the funnel, we reach deep learning here, right? Which is a subset of ML. Deep learning is a subset of ML. It uses neural networks with many layers. Even in civil engineering, we would have gone through this neural network term. So many layers, that's hence it's called as deep, to analyze various forms of data. This technology drives innovation like self-driving cars and the sophisticated speech recognition systems and image recognition systems, etc. Okay. Finally, on the right-hand side, we can we see the transition into the domain of data science. This field like leverages scientific methods and algorithms to extract data from the data, insights from the data. Okay. Sorry, am I audible?
Yes, ma'am.
Okay. Yeah. Okay.
Yes, ma'am.
Yes, ma'am.
Yeah. Thank you. So the data science, right? It leverages scientific methods, algorithms, etc., to extract insights from the data, as I said. So it kind of encompasses analysis, analytics, data mining. Everything comes under this data science topic. So today's session will explore the traditional ML models in terms of performance, We'll delve into specific use cases, like discuss both the opportunities that are present and the challenges they pose, right? So from this, like we can understand, artificial intelligence is nothing but human intelligence exhibited by machines. Okay, any intelligence exhibited by machines is called as human intelligence exhibited by machines is called as artificial intelligence. It's broadly defined into include any simulation of human intelligence, expanding the branching areas of research, development, and investment. It also includes kinds of field like robotics, rule-based reasoning, NLP. NLP is nothing but natural language processing. Okay. So whatever we speak, right, that is natural language, and this machine, it processes our natural language into its own language. What machine doesn't understand our English or Tamil or any language, right? It converts our language into tokens or whatever language it understands, and then it processes this data and gives back us through it talks through natural language, right? That's what we see in Chat GPT. You provide something in natural language and it gives you back something in natural language. But inside that, there is a process where this natural language is converted into tokens, and again, it is converted back into natural language. So all this comes under artificial intelligence. And there is something called knowledge representation techniques also. Right now, we are not going to talk about that, right? Machine learning. Next is machine learning. It's an approach to achieve artificial intelligence. It's like an approach to achieve artificial intelligence. It's a subfield of AI that aims to teach the computer and make it have the ability to do the tasks with the data without explicitly programming. Okay. So we have ML algorithms, we have ML models, where without explicitly teaching the computer, it acts. It uses numerical and statistical approaches and also neural networks. Okay. So kind of recommendation system, image recognition, spam filters, and you have a lot of use cases around it. You can dive deep into that. Okay. So deep learning that's a technique which implements machine learning. It's a subfield of ML. So ML is a subfield of AI. Deep learning is a subfield of ML. Okay. So yeah. Did anyone speak? Okay. So deep learning is a subfield of ML that uses specialized technique, involves multi-layers like artificial neural networks, where layering is allowed there. Then data science is a scientific method where algorithm systems to extract knowledge and insights from the big data. So it's also known as predictive or advanced analytics. It's actually a basic analytics, which we all have done in our projects, everything, right? But it uses algorithms and ML models and also scientific methods, statistics, etc. It all together called as data science. And as you know, data analysis and analytics, we have all come through our projects, like inspecting the data, cleaning the data, transforming the data, modeling the data, even Excel. In Excel, whatever we do is called data analytics. The field may be called data analytics, but we have all used Excel, right? So it's all which we have done. Discovery, interpretation, communication of meaningful patterns in the data. Like we create bar charts, pie charts, all those, like we create meaningful patterns from the data. That's called data analytics. Then data mining, that's the process of discovering patterns in large data sets. Like when you have in large data sets involving methods of intersection, like joining multiple tables, etc., where machine learning statistics and database systems are used. There, it's called as data mining. It's a subset of data analytics. Okay. So I think everyone is clear on this main like this is the one picture which demystifies what is data science, what is artificial intelligence, what is machine learning, what is deep learning. So if someone comes and tells you like machine learning is this and that, you have to tell them machine learning is a subset of artificial intelligence. Okay, a machine which learns by itself is called as machine learning. And what is artificial intelligence? A machine which behaves like a human. Like a human is that is artificial intelligence. And deep learning is something, a subset of ML, where it can process images, it can process voice and everything. That's a subset of machine learning. By this, I'll move to the next topic, like machine learning. So as I said, machine learning is a subset of AI that allows computer to learn from the data. What it does is it learns what? The machine learns from your data, it predicts from your data, and then it improves by itself. Okay, if it's wrong, then it improves in your next prediction. That's what a machine learning does, model does. Imagine you have a magical robot friend or someone. So this robot can do something amazing. It can learn by itself, all by itself, like it just like you learn a new game or a stories, right? The robot learns by looking at a lot of examples. That's what is done here. For instance, if you want to teach the robot to recognize pictures of cats, you show it many pictures of cats and say that this is a cat. The robot remembers what a cat looks like. Then when you show like the robot a new picture, a brand new picture which you have never introduced, it can tell you if it's a cat or not based on what it learned. So it's the same for machine learning model. It's like a robot friend. It's a computer program that can learn from examples and historical data, whatever you feed it, and use that learning to do all sorts of helpful things like recognizing a picture, classifying a picture, categorizing a picture, making predictions, and also like playing games, etc. Okay, so it's like having a clever robot buddy that gets smarter with kind of every new thing it sees and learns. The types of machine learning. So briefly, there are two main types: supervised learning and unsupervised learning. So here, what is meant by supervised learning? Training, I spoke about this training your model, right? Giving examples to your model. So what is training? Training data, how it looks. That's what is this classifications meant. Like supervised learning, the training models on this are labeled data. So your data will be labeled. So if you are introducing pictures of cats and dogs, it will have a label as cat and dog. Then it's called as supervised learning. And unsupervised learning, you won't have any labels there. You'll just introduce so many pictures or data to that, and you won't be having any kind of labels on that. I'll talk in detail about that in the coming slides. But then one more type we have, it's called reinforcement learning. It directly takes inspiration from how human beings learn from data in their lives, right? By trial and error method. When you get a favorable output, you are rewarded, right? When a child is doing a good thing, you reward him. So he will think, okay, we are encouraged and we'll do it again. So those favorable outputs are reinforced, and non-favorable outputs, if a model gives you a wrong output, it's discouraged or punished. So it won't repeat that again. Okay. So that's reinforcement learning, learning from our feedbacks. So we have supervised, unsupervised, and reinforcement learning. The next is AI. Okay. As we know, AI is nothing but it mimics humans, right? Human intelligence. Go to the next topic. Generative AI is what we are all talking right now, right? Sorry for the slide. There is a, you cannot see that, right? So it's nothing but generative AI. It's a subset of AI, as we saw. It was not seen in that big picture, but generative AI is a subset of AI that involves machines, okay, by creating new content. If the machine is creating a new content which is not seen, okay, it generates a new content. That's what ChatGPT does. It creates a new art, it generates a new text, it composes some new music, right? New music which you never heard. So those capacity, okay, to generate something new is called generative AI. It's the same AI, but it generates a new content. Okay, so it is used in various industries like entertainment, design, content creation, etc. right now. So applications of generative AI like text generation, creating human-like text for various purposes. We have seen that. Image synthesis. Now we can generate realistic images, right? Like we have softwares AI like AI tools like DALI and etc. So we can generate realistic images. And also there is something called style transfer, where we can apply this artistic style, one image to another image, can transfer those styles. That's one type. And voice synthesis, like we can create realistic human voices, human-like voices, like we can recreate the voices of humans. That's also generative AI. So the future trends of generative AI, or so-called AIs, right? As we look to the future, it's important to understand that these fields of data science, machine learning, artificial intelligence, and generative AI are rapidly evolving, right? Let's take a look at some exciting trends that we expect in these areas. One of the major trends we are seeing is the continued development of automation, right? Improved automation. So this means that tasks that were once done manually can now be automated using AI, ML algorithms, which like consume so much of manual efforts can be done using ML and AI. For instance, in data science, automation can help with data pre-processing and feature selection and even model selection. In generative AI, we are seeing automation in content creation, where AI can generate text, images, and even music with minimal human intervention. So, and the other future trend we are seeing is enhanced personalization, right? Another trend is the focus of this personalization, where AI is becoming more capable of understanding each individual's preferences and tailoring experiences accordingly. Like in e-commerce, we see when you when you want to buy something, okay, it's recommended by AI, right? How does it know what you want? The recommendation systems are a great example for this generative AI. They like analyze your past behaviors, your searches, your maybe your friends list, etc. Okay, to suggest products you might be interested in. It suggests and recommends products, right? In e-commerce and all those platforms we see. The generative AI also contributes to the personalization by creating content that aligns with the individual's preferences. Like when you want to read about something, you see personalized news articles on that particular topic alone, right? When you're interested in sports, the all your news will be related to that sports. Or if you want to read about some person, you're interested in someone, it all aligns to your individual preferences. So this is a great contribution towards personalization. And at last, we have something called ethical consideration, right? In the Gen AI world, as these technologies advance, there is an increasing need to address the ethical consideration. Issues like bias in AI models, privacy concerns, and the impact of automation on jobs need to be carefully considered, right? Like there should not be any automation for the jobs which has to be done by the humans, and there is many privacy concerns about this AI. And the ethical AI development involves making conscious decisions about data usage, algorithm fairness, and also like transparency to ensure that our advancement benefit society as a whole. Give me a minute, okay. Okay. So I was talking about ethical considerations, right? Like when considering about AI, we have to consider about the ethics also. So we have to be sure that it is using some transparency there, and to ensure that our advancements benefit society as a whole. Okay, so it should be a conscious decision about how we use the data and the algorithm fairness and transparency, etc. So the collaboration of humans and AI. Okay, the future will likely see a stronger collaboration between humans and AI. Okay, already we are there, but AI can assist us in like making complex decisions by processing and analyzing vast amounts of data. But human judgment and creativity remains is essential always, right? Generative AI, for example, can aid artists, writers, designers by providing inspiration and new ideas. So, but the creative process still relies on a human input. That's what I believe. So, before going into machine learning, we'll learn some terms related to machine learning. As we are from different domains, I'll just go through. We talk about algorithm, we talk about coding, model, etc. So, what is an algorithm? Okay, algorithm is nothing but a set of step-by-step instructions that describes how to perform a task. You have a step-by-step instruction, then it is an algorithm. Okay, so algorithms are like recipes. Okay, think of an algorithm like a recipe for making your kind of sandwich. It's a set of step-by-step instructions that a computer follows to solve a problem or do a task. Okay. Just like you follow a recipe to make a yummy sandwich, a computer follows an algorithm to do things like solving math problems. To make peanut butter and jelly sandwich, you follow a specific process and set of steps. Put 2 pieces of bread on a plate. Use a knife to spread the peanut butter on the piece of bread. Use a knife to spread the jelly on the other piece of bread. Then kind of put the pieces of bread together to make a sandwich. Take a bite, right? So this steps, right? This is called an algorithm here. Then you share it with your friends, right? You share your recipe. Once you have created your jelly sandwich, okay, bread and jelly sandwich, you can share your recipe with your friends who now know how to recreate the process. So if you give your friend a specific and clear directions, they can create the same sandwich as yours, just like yours. So this is what an algorithm does. So it should be specific and clear. It should mention what you should do and how it should do and where you should do that. Okay, so it's just an example. You can just go through it. So to a human who has made a bread and jam sandwich, it may look like, I mean, what is this? How I know how to take a bread. I know how to spread that. Okay, but you are giving these directions to a computer, like you are giving these directions to a machine. So these directions must be more specific, must be more clear. A computer might wonder how much bread, how much peanut butter, yeah, right, how much jelly jam. It doesn't know what should I use to spread the peanut butter with jelly and jam? I should use a spoon or a fork or a knife. How do I make a sandwich? What should I take a bite of? Okay, whatever you gave the instructions, you should be so clear and precise. It should be very clear and precise. So your algorithm should always be like that. And there are lines of code, right, in computer science. Even though it's a fun example of creating a sandwich and easy to digest, right? Like algorithms are used in computer science. In our example of making the sandwich, our algorithm had the following goals, right? To accomplish a task, we had a task of making a sandwich, right? To analyze the information, like use the ingredients and materials to accomplish our task. So we had to analyze the information. Then at last, to share results with humans, right? Take a bite and share with your friends. So someone speaking or you have any questions? Jyoti, I think you're on mute. So share the results with humans. Okay. Jyoti, can you please mute yourself? Yeah. Thank you. Okay, so algorithm, to write an algorithm, just think about what you want your algorithm to do. Okay, what is the steps and what you want to do. Write out each steps in a code, then test your code. This is the basic, very basic step. So algorithm, to write an algorithm. Okay, this is what it is. So we all know about flowchart. Okay, so what's the difference between an algorithm and a flowchart? Can anyone post, in the chat, what is an algorithm? Algorithm is, we talk about, like it's a step-by-step description of how to do something. So what's the flow chart here then? You can post it in the chat. I'll just click there. Yeah. Good evening, Sudha. So what is an algorithm? Yeah, okay. So flow chart, you are mentioning about some conditional flow charts, right? Like if else kind of flow chart, right? In a flow chart, we have different kind of representations, but basically an algorithm is a logical step-by-step description of how to solve a problem or like perform a task, as we saw in the example, which can be expressed in various forms, like including natural language or a code. Okay, basically in computer science, they use codes, but there is something called a pseudocode algorithm where you use natural language. So you just write, this is the condition. So if this happens, do this, or else do this. Okay. Yes, a flowchart is a chart representation of series of steps. Exactly. It's a graphical representation. Algorithms, it can be explained in natural language. That's called pseudocode, or as a computer program. In coding also, you can do the algorithm step-by-step process. You can explain that. So they can be written in a human readable language or in a programming language. That's what is called an algorithm. The flexibility of that is it can be implemented in different programming languages. If you write it in a human readable language, right? If this condition happens, do this. So you can implement that in any programming language. You can implement that in C, you can implement that in Python. So any language you can take, but the steps are the same, right? So even if you don't know any language, you know the logic. The logic is what is called as algorithm. So even if we are from different domains, we should know the logic of what has to be happened to the data. So when a data is given, you should know, okay, this is the rainfall data. So we have to do this. We have to convert this from this units from this. That is the logic we have to know. And the programming language is just a language or a computer thing we have to know. Or it is all available online now. So when you give your logic to the computer or AI, it gives you the code in whichever language you want, right? So you have to know the logic. That is the basic of any modeling or ML or AI. So it allows flexibility in choosing your language and also the platform. That's an algorithm. And the flowchart, as you said, on the other hand, it's a graphical representation of an algorithm or a process. The same thing, it's represented graphically. Okay, using visual symbols and shapes to illustrate the flow and the steps involved and the hierarchy involved. So the flowcharts are often used to make like complex procedures easier to understand and communicate. Okay, so naturally the flowcharts are graphical. They use symbols like rectangles for processes, diamonds for decisions, and arrows to show the flow of the process. They provide kind of visual representation of an algorithm. Communication purposes like flowcharts are often used to communicate complex processes or algorithms in a more kind of visual or easily understandable way. And they are particularly useful when explaining processes to a non-technical audience, right? When I first show what is the classification of the machine learning, I just showed a flowchart, right? Like the hierarchy of how it is classified. So whoever is not into that domain can also understand what it is. And also for the implementation thing, flowchart can be represent an algorithm. It is not the same as writing the code. It is more like providing a high level visual overview of a process of algorithm, right? We have something called architecture for every project we deal, and there we like whatever components we use there in the project, whatever logic we are going to use, whatever cloud or what is the process we are going to follow. Everything will be given in a diagrammatic, like graphical representation. That's called an architecture of the project. Okay, so both are needed for modeling and AI kind of projects. So you know what is a flow chart and what is an algorithm. Move into the next slide. So I was talking about ML model, right? What is a model now? Okay, what is model? Imagine building a model of a car using Lego bricks. Okay, there's a what's with kids play, right? Lego blocks. So it's not a real car, but it helps you learn how the car is put together and how it works, right? In the same way, a computer model helps us understand things like predicting weather or recognizing pictures of cats and dogs, etc. But it is not the actual thing. It's like a model of whatever it helps us understand things. That's called a model here. Okay, that's the concept. So you don't confuse it. What is this is a physical model, and a computer model, something like it helps us understand things like predicting the weather or recognizing those pictures or categorizing them, etc. Okay. What happens inside the model is some mathematical calculation. So you will have some calculations like y is equal to ax plus ax1 plus bx2 plus cx3. Okay. So these x3, x1, x2, x3 are the features or parameters of this model, and whatever you're giving some weightages to that parameter. Okay, and then you do some calculations, you predict what is the value. That is a model. So it is nothing but a mathematical calculation. But for smaller data, you can just calculate it and find the predict it. But for a huge amount of data, you need a machine learning model. So it learns itself. It gives the weightage itself. You no need to say what is the weightage, what is A, B, C, what is X, Y, Z. Right? You just give the input and expect what is the output, and you will get the prediction. So that is what a model does. It learns from the historical data, finds its own weightages for the calculation for the equation, and then it predicts whatever you want. That's called a model. Here, computer model. Okay. So machine learning models. I'll just explain a few models. First, we'll go through the machine learning process. Okay. So what does the machine learning process happen? First, as we saw, data pre-processing. In all the projects, we do this, right? When you get the data, you import the data from somewhere, then clean the data, split it into training and test sets, right? Here we do that, training and test sets. When you get the data, you split that into training and test sets. Then modeling. What you do next, you do the modeling. You build the model, that is the equation. Okay, you just say which model you want, and machine learning itself builds the model. Train the model using the historical data, whatever you have. Okay, you have a historical data of rainfall data. You should have the final result, like rainfall of a particular area. You can have the pin code of the area. You can have the temperature and humidity, whatever related to that rainfall or weather data. You can have that, and finally, in one column you should have the rainfall data. So this is the training data you will be feeding to your model. And finally, you can predict after a few trials when you provide a pin code, okay, of an area, and then you give certain parameters and ask the model what would be, how do you predict the rainfall of this place on this date? It predicts from those historical data and tells, okay, if the humidity is this much, if the weather is like this, if it is in this pin code area, the rain, it likely to rain tomorrow. Okay, that is a prediction made by the model. And evaluation, whatever the model does, we cannot just accept what the model, right? There can be errors in the model, so we have to like calculate the performance metrics from any model built. So there are certain performance metrics where we make a verdict like whether the model performs well, or you have to again retrain the model, rebuild the model, or whatever you want to do. So this is the basic steps or basic processes involved in the machine learning. You first pre-process the data, you model, then you evaluate the model. Okay, so as we saw in the first one of the slides, the types of machine learning. We'll go in depth. Okay, supervised learning. As I said, it has labeled data. Maybe it was not so clear for you. The supervised learning is like having a teacher, okay, to help you learn new things. Imagine you have a teacher who shows you a picture of different animals and tells you their names. You learn to recognize each animal by its features. The teacher provides guidance, right? The teacher shows a picture of a cat and she says, this is a cat. She shows you a picture of a dog and she labels it as a dog. So you understand with the help of guidance from a teacher. Okay, in supervised learning, a computer is like a student here, a machine is like a student, and it learns from the examples. For instance, it learns to tell the difference between cats and dogs by looking at the pictures that are labeled as cat and a dog. The picture will be labeled. So picture 1, this is a cat. Picture 2, this is a dog. So you will have labels for those pictures. So computer use these labels to learn and make predictions. So you have a teacher, you have a guide here. That's what is an example here, label. So when you have a labeled data, that is called supervised learning. As I said earlier, you have a rainfall data, right? And in the rainfall data, you should have whether it has rained this day and what are the parameters of that day. That day it was the temperature was this, the humidity was this, and this was the area. So you should have all this data, and finally in that column, you should have whether it rained or not. So that is a label there. Okay, it rained or not, no rain, rain or no rain. So this machine learning model looks at all those examples and gives weightage for those parameters, temperature, humidity, everything. And then if you give a new data, okay, if you show a new cat or dog picture, what your machine will do, it now knows, oh, the cat, it looks like this, so this is a cat. Because it has learned from the labels you have provided already. The teacher has already taught it that this is a cat, this is a dog. By looking at numerous examples, a lot of training data, it can predict that this is a cat. It can confirm that it's a dog, right? That is supervised learning when you have a label. Unsupervised learning is like more like exploring and discovering things on your own. Okay, like on your own without a teacher. If you don't have a teacher, imagine you have a big box of colorful balls. You don't know what color, which is what color. You don't know what is colors. Okay. You want to see if some balls are similar in color, but you can say these are similar in colors. Oh, you don't know whether it's yellow or red. Okay, this is the first time you are learning colors. Okay, but you can just by seeing, you can sort it out, all the yellow balls together, all the red balls together, all the blue balls together. So you do that by sorting out, by finding the similarity, right? You might group them without anyone telling you which one goes to the other. You won't mix red with the yellow unless we have some problem with our eyes, right? So, the same is what we do in the unsupervised learning. You don't have any labels. You don't have cat. You have pictures of cats and dogs, but there is no label saying this is cat and this is dog. Okay, but by seeing the pictures itself, you like similar. This is a similar kind of picture. So I'll put it into the cat category. I'll put not cat category. You don't know what is cat and dog, right? So you'll put it as category 1, category 2. But those are two different categories. You split it without knowing the labels, right? That is unsupervised learning. So you might like the computer doesn't have a teacher here, right? Instead, it looks for patterns. Here, what you look for similarities in data when you're using it in data. Okay, you can like find groups or similar items or like uncover hidden relationships in data also, like without being told what to look for, right? I hope you got the difference between supervised and unsupervised. Unsupervised is something which we don't have labels for. Then reinforced learning. Okay, reinforced learning, as I said, it directly takes inspiration from how human beings learn from data in their lives. Okay, so an algorithm that improves upon itself and learns from new situations using trial and error method. As I said, it's favorable outputs are there. Then you are encouraged or reinforced. Like if your teacher gives rewards if you do a good thing. Okay, so the model understands, okay, the prediction is correct. So I'll use this to my data. I'll add this to my data. And then if you're giving a wrong output, the teacher punishes you and it's discouraged. So the model, it learns from the punishment. Okay, so this is a wrong prediction. I should change myself or the logic behind whatever I have done now. So it understands and learns from its own ability. That's like a human being, how when a child goes and touches a fire, it knows it's hot and I should not do that, right? From the punishment, it understands, the model understands how to behave. That's called reinforcement learning. That's reinforced, like it means from the feedback of a data scientist or someone, it understands that this is wrong, this is correct, and this should be done, this should not be done. That is reinforcement learning. So in summary, like supervised learning, it's like learning with a teacher who provides guidance and labeled examples, while unsupervised learning is like exploring and discovering patterns on your own without any specific instructions. Both are important in machine learning. Okay, so and they help computers to solve different types of problems. We'll talk about that. Give me a minute. Okay, there are furthermore classifications of ML models. You can just look into the picture and understand. There is something called classification and regression. Okay, first we saw supervised, unsupervised, and reinforced. And under unsupervised, we have classification and regression. Classification, as the name suggests, is nothing but sorting things into different groups of or categories. Imagine you have a box of colorful balls. You want to separate them into red balls and blue balls. Okay. Then the computer does that classification, right? Whether it will rain or it won't rain. That's a classification problem. Whether deciding if an animal, like it's a cat or a dog, based on its features. If there is two things to decide, or if two or more things, you can have multi-classification also, right? Class A, class B, class C. But you sort it out and classify it as different groups, then or categories. Then it's a classification use case. Okay, if you are checking a mail and saying whether if the model, okay, not you, if your model is going to find out whether your email is a spam or not spam. That's a classification problem. So what is regression? Regression is nothing but when you're predicting something called numbers or values. Okay, if you're going to predict whether it will rain or not, then that is a classification problem. If you're going to predict how much rain it's going to be, I mean, how much it's going to rain, what is the how much centimeter is going to rain? Okay, that's a value, right? It's a number or value, can be anything, any number. So when you're predicting a number or a value, you want to say some numbers, right? Let's say you want to guess how many candies are in a jar. Then you can use regression to make that educated guess, right? It's like when you try to figure out how tall you will be when you grow up, right? That's a number, right? That's regression. And regression also like helps the computer make predictions, like estimating the cost of something, right? Like you want to estimate the cost of a house in this locality. The cost can be any number. So that's a regression problem. Or if you want to estimate like whether this house of this in this place, this house, okay, it will be sold or not. That is a classification problem then. Okay, but if you are going to predict the cost, then it's a regression problem. How hot it will be on a particular day, or will it, how hot, that would be a regression problem. Okay, so you have to understand which kind of model you have to use, what is the use case there, etc., for your particular project. If you're going to just predict whether it will rain or not, you have to use classification. You want to predict how much it will rain, then you have to use regression. So in summary, like classification is like sorting things, and regression is like making predictions or about numbers or any values. These concepts are like very important in machine learning, okay, where computers use them to make decisions and solve problems. Nowadays there are like ML models and everything pre done. But knowing the basics is very important. You have to know why it is used, what is used there. There are models, right? Whatever I have given there, the different models, decision tree, random forest, SVM, etc. But which model to use for which use case? Okay, so for that we have to know the underlying logics and why it is used and how it should be used. So under classification, we have all these models like naive-Bayes classifier, decision trees, support vector machines, SVM, random forest, k nearest neighbors. And under regression, we have linear regression, neural network regression, support vector regression, decision tree regression, lasso, and rich regression. Okay. Then unsupervised learning, as I said, it learns by itself, like it categorizes clusters, right? Cluster A, cluster B, cluster C. It can only cluster the data to A, B, C, like that. Okay. So under that, we have k-means clustering, mean shift clustering, DB scan clustering, agglomerative, and Gaussian mixture. Then reinforced learning, there we have some feedbacks and decision making is done there. So there it's Q learning, R learning, TD learning. So these are some names. Just keep in mind that these are some models which I use. The main thing is machine learning, supervised, unsupervised, reinforced, and undersupervised classification and regression, and unsupervised it's clustering. Hope you all got an idea of what is machine learning, the basics of the classification, right? Like supervised or what supervised learning is. Okay, we'll just go into one of the model, like tree-based model. That's a type of model where decision trees, which follows random forest and gradient boosting. Okay, all these follow this tree-based modeling. We'll just explain, go into that one kind of model, and you can delve deep into other models also if you're interested. Okay, this is kind of tree-based model. It's a type of model in machine learning that helps computers make decisions. Okay, so it's called a tree-based because it works a bit like a tree with branches. Though it looks like a flow chart, it acts like a tree with branches. It's like a fun game with computer to play or solve a problem. I'll just explain that. So it's like a game of 20 questions. Okay, imagine you have a big list of animals and you want to figure out which ones are cats and which ones are dogs. So the tree-based model is like asking a series of questions to decide if an animal is cat or a dog. Here is how it works. You start with a big question like, does the animal have a fur? Okay, this is the first branch of the tree. It's not shown here, it's shown as ear shape, but whatever question, that will be your first or root. Okay, then based on the answer, you either go to the left or your right on the tree. If the answer is yes, you might ask, is it a big animal? If no, if the answer is no, you might ask, is it a small animal, right? You keep asking questions and following the branches until you reach the final leaf at the end of the branch. That's called the leaf, which is cat or a not a cat. This is how the machine understands itself. And for each node, right, we are seeing a question here, but that will be actually a model there asking and giving different weightage to different parameters there. But this is simplified just to explain what is that. Okay. Then the last leaf, it tells you if the animal is a cat or not a cat. Okay. So the tree-based model is like a decision tree. The decision is taken by the tree where you ask questions step by step to find the answer. It helps the computer decide things like whether an animal is cat, or based on the features, right, or the characteristics of that animal, you finally land into a place where whether it's a cat or not a cat in this example. Okay, I hope you got it. So one more example of decision tree. Here in the first example, first you are like trying to find the risks to prevent a heart attack, right? Whether you are a low risk person or a high risk person. First, this is a doctor, maybe a doctor model. Okay, AI. The doctor AI, what it does, asks the person, robot, it asks the person, what is your age? Okay, if he says about 30, then you will go to this right hand side branch. So the bot will ask you, are you a smoker or not? Okay, if you say yes, then you are gone into that high risk category. Or if the age is low, and if you're not a smoker or your weight is less, then you will be a low risk category of leaf node. Okay. So there are many kind of nodes there. There will be many kind of nodes there, but this is just a basic thing for your understanding. The same with the other example also, like whether what's that, you have cold or not, something like that. Okay, so it will all be decided by the questions and the follow-up answers. So this is called as a decision tree, one decision tree. Okay, but the model will be having multiple decision trees, and it will take the average of everything. I'll explain that. So the limitation of this one decision tree is like overfitting, right? What is overfitting? It will capture all the noise in the data, and it will capture everything in the data. Whether it's a noise or not, it won't bother. There will be highly variance, and even for small changes in data, the prediction will be highly variant. So to overcome this limitation, we are using random forest. Okay, as the name suggests, forest means a group of trees, right? The same thing here. Random forest is like having a group of friends help you make a decision. Okay, if you want to make a decision, you ask all your friends, right? Like instead of just one person or one tree making the choice, you ask your friends, that is the trees here, for the opinions, and they all vote on the best choice. Like when we saw the first tree, it said the vote like it is a cat. Second tree also says it's a cat. Third tree says it's a dog. Okay, or something. So when you take the vote, maximum vote, right? When we take a vote, we'll take the which has maximum counts. So here cat is the answer. That's how the random forest acts. Decision trees. Okay. Then all vote on the best choice, and this helps make better decisions, like choosing what game to play or not, or what to do or not. Okay, so it introduces randomness during tree construction. It picks only certain features to build each model, and this may mitigate overfitting or improve generalization. Okay, it doesn't pick, or there is no bias here, first of all. So you will have a lot of decision tree, and the group of decision tree decides for your final, that's what's done here. So this is random forest. As we saw, random forest is combining multiple decision trees, reduces overfitting, and increases accuracy, handles high dimensional data here. So you can work well with large number of features, as I said. So decision tree 1 may use 10 features, first 10 features. Okay. Decision tree 2 may use second 10 features. And it's not necessary that all the features are used for all the decision trees. So there is the bias may be avoided here, and it can handle a large number of high dimensional data or big data here. Feature importance, like provides insights into the importance of each feature also. So we have something called feature importance, and the random forest model will decide which feature is most important when you predict that there will be a rain. Okay, this model explains you which is the most important feature, which is the least important feature. So maybe you have a pet in your house or not. Okay, that may be a data there, but that will not be useful for whether it will rain or not, right? So that feature is not at all important for your analysis. But the humidity of a place, that will be a very important feature for your analysis. So those important features, whether you mention it or not, your model will capture it and it will display the first 10 or whatever your code wants. Okay, it will display your important features. So these are the advantages of using a random forest model. So how a random forest model at a high level explained earlier. Okay, randomly select a subset of data. You have a data, but you just randomly pick some data. That's called bootstrapping the sample. Then randomly select a subset of features also for each tree. Features are nothing but those columns. Okay, humidity, temperature, whatever columns you have for the final output. Those columns are called as features or inputs you give. Okay, those that if you have 10 or 100 features, you will just take a subset. You will just take a 10 subset for each tree, that too randomly. So and also like step 3 will be building multiple decision trees for this forest. As forest will have different trees, right? So you'll build multiple decision trees using these subsets. The data will also be picked randomly, bootstrapping. Then your features also will be picked up randomly as a subset, and then your trees will be built using these subsets. Okay, so the randomness is ensured here. There is no bias involved here, and the model can predict according to that. So combining all the predictions, step 4 will be, we'll have multiple trees built. Okay, you are going to build 100 trees, for example. Combine all the predictions from all the trees. Okay, if it's a classification problem. So if you are going to check whether it will rain or not, that's a classification problem. What you will do there, you will get, when you have 100 decision trees, 80 decision trees say it will rain. 20 decision trees says it will not rain. So majority vote goes for it will rain, right? So finally the model will predict it will rain. So for this classification, it uses majority voting. And for regression, so the cost of or how hot it will be, like it's a temperature, right? Like so it will be different numbers for each decision tree. It will be, some will use 25, some will give 26, 27, 20. So all those are different numbers. Here what you will do, you cannot take majority voting. So for regression, from all the trees, you will take the final value and then you will average that and then provide us a prediction. This will be the this is the temperature for the day. Okay, so that will be the result of your model. When it's a regression problem, it will be averaging. When it's a classification problem, it's a majority voting of all the outputs from each tree. So evaluation metric, right? Evaluation metric is like a report card for a computer model. Okay, you have a computer model, it predicts that it will rain. How do you know it's correct or not? You have to evaluate it. When a model tries to do something like guessing how many jelly beans are in a jar, like it's an example. Okay, so we use a metric to see how well it did, right? The model predicts something and you want to know how well it did. It's like giving the model grade to see if it's really good at guessing or not. It guesses something and you want to know it's correct or not. So we need some metric to evaluate that. So for that, we have something called confusion matrix. Confusion matrix is like a chart that helps us see how well a model is doing. So this is the matrix we have for any model. Okay, there is something called predicted class and actual class. So as you see, there is positive and negative on both the sides. So if it's a true positive, it means like the model correctly predicted when actually it's correct. Okay. So for example, if you take, it is going to rain today. Okay. And the model has also predicted that it will rain today. Then it is the true positive. true positive data, and it's a true negative means it will not rain. Actually, it will not rain, and your model has also predicted that it won't rain. Correctly predicted negative instances. That is true negative. So that diagonal is all true. It's all correct. Okay, your model also predicted whatever is going to happen actually. But what is the type 1 error? We'll go from type 1. Okay, false positive. Incorrectly predicted as positive. Actually, it's negative, but your model predicted it as positive. Okay, so that's called as type 1 error in your model. And if something happens like this, okay, false negatives, incorrectly predicted as negative. That means actually it's positive, but your model predicted it as negative. So both the cases, type 1 and type 2 errors should be avoided, and there should be a balance between these two, right? So there are cases where you should not have a false positive, or there are cases where you should never have a false negative. Like take an example of incorrectly predicted as positive. Okay, maybe a COVID test. Take it as an example. People who are undergoing COVID test, there is an AI model. It predicts whether he has COVID or not. Okay, according to the symptoms or whatever he had, the blood test or whatever, it predicts the whether he has COVID or not. But it predicts incorrectly as he having positive, like he is COVID positive. Okay, but here the impact is a little bit less because maybe he has to undergo that he has to sit at home. He has to be at home for 10 days. He has to take medications which he should not take because he doesn't have COVID. Okay, actually he's negative, but the model predicted this as positive. That is one kind of error. And the false negative, the person actually has COVID. Okay, but the model predicts him as negative. You don't have COVID. You can go free outside. Okay, he goes, spreads it to everyone, and that's actually a drastic mistake, right? So we should avoid false negative more here in this model, right? So we should avoid type 2 error in this model. So according to the use case, you should know, a data scientist or a person who works on that should know which error should be reduced for this kind of use case. So type 2 error or type 1 error, which should I reduce for different use cases? Maybe for different use cases, it will differ. Okay, in an airport, when they're screening for some weapons or something. So if it's not a weapon, but they are screening it and mentioning that you are some, so it's a negative thing, right? So all those things we have to notice which kind of error we have to reduce another. So I hope you understood what a confusion matrix is. It's a matrix between the predicted and actual class. Okay, chart helps us to see how well a model is doing, and it helps us to see how many times the model got things right and how many times the model got things wrong. Okay, it's like keeping a track on how many questions you answered correctly, how many you answered wrongly in a quiz, something like that. So it's like keeping track of those. So keeping that confusion matrix, you can there, as I said, there are some evaluation metrics. Okay, there are some metrics to find whether you do good or not. You have something called marks in your exams, right? Like same thing. Model, you have some metrics like accuracy, how accurate your model is, the precision and recall. Those are some numbers which tells how your model is. Okay, F1 score, then confusion matrix. When you see the table itself, you'll know how the model is behaving. So these are the evaluation metrics. First, I mentioned about the confusion matrix because all the others come under that only. Okay, you should know first what is true negative, false positive, etc. That's why I mentioned that first. So precision, what is that is it focuses on the accuracy of positive predictions, whether your predictions are positive or not. That is mentioned there. Okay, it's a ratio of true positive to the number of positive predictions. You have a certain number of positive prediction. Out of that, how much is really true? High precision means that the positive predictions made by the model are highly accurate. Then recall is something like it's also called as sensitivity. the model's ability to find all positive instances. You have 80 positive instances, and how much negative you find or not. Okay, you should find all the positive instances. That's called recall. It's the ratio of true positive to the total number of actual positive instances. Out of actual positive instances, if it's 100, you at least have to find 80 or 85. Okay, then your recall will be 80 or 85. That's a good model metric. Okay, so high recall means the model captures a large portion of actually positive instances. Here is how to decide which metric is more appropriate when you have a type 1 error, like as I said, airport screening, or like any errors like in the COVID or other tests. Okay, so basically, you should know where to use and how to use, which kind of error you must avoid, and other things. So whether you have to prioritize precision or whether you want to prioritize recall, you should know that. And also there is something called F1 score, where it's a combination of both the precision and recall. So you should have a balance between these two errors, right? It's a good choice when you need a balance between the precision and recall. So that's where you can use metrics like F1 score. Any notes till now? I'm just moving on. So the next thing is hyper tuning, which you use in your model. Okay, you have to you have some settings like in your video game or whatever you use. You have settings, and you can change that. You can adjust that, right, to make it like you can change the volume or you can do anything, right? And so in ML models also, changing means you're changing, or tuning means like there are some settings where which makes your model work better. Okay, so for example, if you take a random forest, if you change the number of leaves, or you change the number of branches, or you change the number of length of the tree, okay, number of nodes of the tree, you found there was a root, there were branches. So you can mention all those parameters in the model. So you can change those parameters and check how the model is working. So if you're getting a F1 score, a precision or recall score of like very low, right? Like 40%, 40 or 30. Okay. So the model is not doing well. What you will do, go back, change these parameters, adjust the settings, like change the number of decision trees, change the number of leaves, change the number of branches, change the number of nodes, etc. And then you can hyper-tune the model and check whether the model is working better or not. It's like changing the game's difficulty level to win more easily, or you make it more difficult or not. Okay, so you can change that and tune your model. And the other thing you use here is cross-validation. It's like practicing a magic trick, as you can read that many times to make it sure it works every time. Okay, so you do it every time, cross-validate it using a lot of subsets from the same data. Okay. When we want to know how good a computer model is, we are testing it on different parts of the problem to make sure it's really good at solving it. It's like doing the same trick, yeah, in front of different friends to make sure they're all amazed, right? So it's kind of that. Cross validation is kind of that. So we'll just go through this random forest algorithm again. Split the data set into training and test set. Okay, if you have a data 1000 records, if you have, you split 700 data for training and 300 for testing. Okay, create the set of decision trees. Then for each decision tree, randomly select a subset of data with replacement. So that can be replacement. That's called bootstrapping. And also choose a subset of features, build the decision tree. For classification, the majority votes is taken, and combine the trees, majority vote. For regression, as I said, it's averaging the model. Okay. So optionally, you can use the fine tuning for adjusting the hyperparameters. You can use cross validation. All those you can do to fine tune the model and make your model more good. Okay, too. get your evaluation metrics boost, etc. So as I said, there is something called training data set and testing data set. Okay, the step is called as splitting the data set. When you have 1,000 records, you make it 70-30 ratio or 80-20 ratio. You use only the 70% or 80% of your data for training your model. The rest of it is not shown to the model. You don't introduce the testing data to the model. You just train the model using the training data set. And then finally, when your model is ready, you test it using the test data set. You know the answer, right? Like in the test data also, you have the label, whether it will rain or not. You have that answer. You have the testing data, which is not given to the model. Using these parameters, test it, whether this model is giving the correct value or not. That's what testing data is used for. So usually we use 70-30 or 80-20 ratio. Okay. So this is the main and first step in building a model in splitting the data set. Then cross validation, as we saw, the picture is not there, right? So training data and test data is there. Use that training data and test data in folds or different groups or subsets, and then use it for each time. Like each time it uses different kinds of splits for this testing. And this is called K fold. When you give a number, K is called here 5. Okay, you use only 5 as a subset. And for each iteration, you take 5 sets. Okay, so I'm not going to walk through code and all. So the other thing is called as gradient boosting classifier. This is nothing but the same thing. Okay, as we saw in the random forest. Here, what we do is we are choosing a weak classifier. You have certain data. Those are that black dots. You want to classify it as red or blue. Okay. Then you classify. You have a line there, and above your line you have some blue, and below also you have some blue mixed up with the red. Okay. So which is the wrong data? Take those. So the blue in the red is the wrong thing, right? Make it bigger. Give more weightage to the wrong data, wrong prediction, so that. And in the second part, the red is in the wrong position. So red will be given more weightage in the second classifier. As you can see, the weight is increased for the wrong thing. Okay, I hope you understand. Above the line, those two blue should be red actually when it's classified. There's a line called classifier, and below that red should be blue. So those two are wrongly classified things, and they are given more weightage in the next iteration. So it's given more weightage. Now again it's classified. The model runs and there's a line given there. Okay, now it classifies this as one group, the other two as one group. Now the right hand side is correct. Okay, but the left hand side, those two blue are wrong. Again, it's increased weight for that wrong prediction. And then again it gives into the model, feeds into the model. And then again there is a classifier line drawn, weak classifier line drawn. Okay. So now the left hand side, it's all correct. It's grouped into red only. But in the right hand side, there is a small red spot among the blue. Okay. So again, these classifiers are drawn, and finally we'll have a combination of all these classifiers, and we'll finally find which is the proper line or demarcation between these two kind of categories. This is called as gradient boosting classifier. As we saw in the random forest classifier for trees, it used a tree-based thing, and from the questions it came up to the answer and predicted how it comes. Here, what it does is adding more weightage to the wrongly classified thing, and finally getting into the answer. Okay, it's an ensemble of all the classifiers, and finally we have gradient boosting. We are boosting the wrongly classified thing. That's this kind of model. So we can use, there is differences between random forest and gradient boosting models. You can use whichever you want. And first model, each learner is trained independently. The next one is trained according to the errors. It corrects using the errors from the previous tree or previous model. Okay, so making predictions. Final prediction is an average of all the prediction of all the trees in the random forest. Here it's given by the weighted sum of the collection. Same, you can just read it out. Optimization reduces variance, here reduces bias and variance. Overfitting, less prone to overfitting. This is more prone to overfitting as we are doing it right until the data is correct or perfectly fit. We are doing it again and again. So overfitting is seen here in gradient boosting. So, and in hyperparameters, only few hyperparameters are used in random forest, but here more hyperparameters. Parallelization, it can be trained parallelly. Okay. Parallelly, you can build more trees and then finally you can group it. But here you cannot train it parallelly as one tree is the root for the other tree. Okay. From one tree, the wrongly predicted thing, you give weightage and then you pass it to the other. It's done in a series or sequentially. So there is no training run in parallel. Okay, there's one more kind of model called SVM, support vector machine. So data points in a space, and you can just go through the support vector machine on your own. Okay, just want to give you a heads up on that. Okay. Hope everyone got an idea on what is data science, what is machine learning, what is AI, and how it's used, where it's used, and we went in depth to the machine learning. What are the types of machine learning? And we discussed about two types of machine learning here: random forest and then gradient boosting. Okay. So, any doubts?
Thì đâu là ngoài nghỉ đã có tôi mang về.
I'll stop sharing. If there is any doubt, please put in the chat or you can come online and speak. We are going to end in 2 minutes, I guess. Till late, but if you have any doubts, you can connect me offline also, right? You can get my email ID from Lavanya ma'am or Vijay Master, Sujatha sir. Yes, ma'am. Yeah. Okay. So, example with civil engineering, yes, there are many use cases out there. So, what kind of use case are you looking for is according to the model and according to use case, you have to decide upon how to use it. I'm just explaining you the basics of how it's done. So basically, you have to know a programming language, Python or R. That's a very basic thing, and it's like normal English only. So we can learn that online. Okay. So Python is needed for this kind of modeling, and you can use even Google Colab. It's free, ultimately free. So you can use that, and you need Python, and you need to know what are the models and how it's done, and it's all like practice, right? You can have practice with the smaller data. There is a website out there called Kaggle. There are a lot of data sets out there. You can use those data sets as an example or use your own data and then play with the data there. Okay, just try with building a small model like classification or regression, smaller models, and then you can go in deeper. First, take a data, just clean up the data. You will have a lot of errors in the data, right? First, you need to clean up all those. So what is the kind of logic you want to use that you can use? Lavanya ma'am, is there any questions you can like?
Sujatha ma'am, there's a question in the chat box.
Oh, okay, let me check. Disaster management. Okay, the ethical challenges. So what do you mean by ethical challenge here in disaster management? So maybe take disaster management like flood or something. Okay, so there can be like when you distribute some resources like food, water, or medical aid, there can be inequities, right? Like when it's prioritized according to the ethical concerns of vulnerable groups or like marginalized communities, there can be challenges there when using AI. So that's what I said. When using AI, there should be some human touch there. Okay, in every project, you should not give the full authority to AI. Actual class and predicted class. Okay, so actual class is nothing but what's going to happen actually. Okay, predicted class is something predicted by the model. So actually, the person has COVID. Okay, but the model is predicting him as negative. That's the predicted class and actual class. And that positive and negative means in that case, it's a positive COVID and negative COVID, and it can be anything like rain or not rain. Here positive is it will rain, and not rain is not 0 or 1. Okay, the model will not have rain or not rain. It will only have 0 or 1. Okay, or if you have different categories, 1 or 2, cat or dog, it will only have 1 or 2. Then you will name it as cat or dog. So prediction and what is actually happening, that's actual class and predicted class. How to verify the correctness of the solution or output from AI. So that's what I said. You have to use the evaluation metrics. For any models, we should use the evaluation metrics and check whether the model is at least performing like how it's performing. AI in disaster management, it's how we feed, right? If you are inputting your data is rubbish, your whatever output you get is also rubbish, right? What are you data you provide inside a model, that's what the output will be. So using AI in disaster management, first we have to understand what data we are going to input. Okay, so it's okay regarding how we give the input. And response time to alert the people's it's according to the response mode. Okay, if I'm going to send you a WhatsApp message, what will the people who are not having a WhatsApp do? Okay, it's all decided by how we are going to alert them, through WhatsApp or through mail or through messages. So we have to know what kind of response mode is needed for those people and which will suit them. Nature is unpredictable, exactly. Then how we trust the predicted data and disaster management. There is no like something called trusting the predicted data, right? Like we are not going to trust it 100%. As I said, the model is said to behave well if it has an accuracy or a evaluation metric of at least 70%. So what happens to that 30% is like said. We cannot predict that fully 100%. It's a model. We can just predict that 70% of data, at least that 70% of time, it is predictable. That's what we are at least trying that. Okay, that itself is a huge change, and we are all trying for that. Any other questions, or we can wind up around 5 minutes. So hope everyone got an idea of what's special learning model and everything. I just try to search on these topics and learn more. There are a lot of resources online. As I said, Kaggle is one of the resources where you can get data sets to practice. And also you can check online. There are many like ample number of videos there in YouTube, and there are people who like have a series of talks and other things. So you can just learn it. It will be very useful for civil engineering domain also, because for everything, right? Like predicting and choosing, categorizing, in all the fields we use this. So even in health field, engineering field, all the fields we have to use this AI. And not only AI, machine learning we can use. AI can be one step ahead. Like you build a chatbot where you get an answer of whatever you have built. Okay, you have a model which says whether it predicts whether it rains or not. You want a chatbot. Okay, you prepare a website. There's a chatbot where you speak to the bot and understand whether it happens or not, or what's the house price going to be in this price. You predict according to the given features. Okay, number of bedrooms. Now this is the plot area. This is the square feet. This is the area. What will be the house price here? You can predict that, and you can have a website. You can have a chatbot. You can like generate new things using Gen AI. You can learn all these things. You can Google it. Even I learned in that way. There are courses out there. So it's all new for everyone. So it's a new topic, Gen AI, and anything. So we can all like learn it online. Just have a guidance from someone.
Thank you, ma'am.
Thank you, Lavanya ma'am.
Thank you for your wonderful session. Dear participants, it's the time for the second session. Let's invite Dr. Saravananan sir. Welcome you, sir. I invite Mr. Harish to welcome Dr. Saravananan sir through his welcome speech.
Greetings, Mr. Saravanan sir. Dr. Saravanan obtained PhD degree from IIT Roorkee campus. He has been engaged in teaching and research over 20 years. Presently, he is working as professor in NIT Trichy campus. He has published 80 plus national and international journals and 50 plus national and international conferences in his professional career. He is a member of various professional bodies. He has published 15 plus books and he has visited many foreign countries. With this introduction, I would like to invite Dr. Saravanan, Professor, NIT Trichy, to proceed the session. Welcome you, sir.
Saravananan sir, you can proceed with your session, sir. You can share the content.
Hello. Am I audible? இது கேக்குதா? இல்ல நீங்க சொன்னீங்கன்னா எனக்கு ஈஸியா இருக்கும். Hello. ஓகே மேம், என்னோட ஸ்கிரீன் விசிபிளா இருக்கா? நான் ரெண்டு ஸ்கிரீன் யூஸ் பண்ணிட்டு இருக்கேன். ஓகே. அதுதான் என்ன ரெண்டு ஸ்கிரீன் யூஸ் பண்ணிட்டு இருக்கேன். அதுக்காக கேட்டேன். ஓகே, ஒரு நிமிஷம். இப்ப பாருங்க. ஓகே, தேங்க்யூ. Good evening, Mohan. Hello. I'm getting echo. Is it fine now? Pardon?
சார் ஏதாவது ஒரு சிஸ்டம்ல ஸ்பீக்கர் ஆன் பண்ணுங்க சார். நீங்க ரெண்டு ஸ்கிரீன் வச்சிருக்கீங்கல்ல, ரெண்டு சிஸ்டம்ல.
Okay. Close the login. Now is it fine?
It's fine, sir.
I'll share the screen one. Can you tell me whether it's okay or not? Is it my second
Okay,
screen?
sir.
Would you be able to see this second screen?
No, sir. Sir, I can see only the first slide, sir.
That is first screen. Could you be able to see?
Yes, sir.
Okay, then fine.
Okay, sir.
Okay. Good evening. Thanks for the introduction. And today I would like to take the session on AI application on disaster modeling and management. So everybody knows that what is artificial intelligence applications or machine learning or deep learning. Today's presentation, I will give you a small introduction about the machine learning and deep learning, and I will go for the various case studies, how we can implement the machine learning technique for various disaster applications. Today, my presentation outline will be something like introduction of AI and machine learning. Then I will handle the session like application of climate change and machine learning in natural hazard modeling. So the first case study will be the comparison of conceptual and machine learning model for stream flow modeling in the Godavari catchment, how this historical and projected CMIP6 future climate scenario data will be used for determine the stream flow data. Then second case study is how the remote sensing GIS technique incorporated with the machine learning technique for assessing the flood susceptibility in one particular catchment. So in this study, we took the Chennai basin and we proved that what are all the area is highly vulnerable for flood susceptibility. Then the third case study will be something like how to use the machine learning technique for landslide susceptibility mapping. The fourth study will be machine learning applications for forest fire accessibility for the Western Ghats using machine learning and GIS technique. So with that introduction, I would like to continue my session. So most of them, we all know that what is machine learning and what is deep learning technique. Machine learning technique is subset of the artificial intelligence. So artificial intelligence will contains everything. It includes machine learning and deep learning. Mostly the deep learning technique will be used for image-based analysis. Almost both the technique will work similar approach, but the machine learning approach is more suitable for the numerical type of data, and deep learning technique mostly we will use it for image-based type of data. So in general, we can classify the machine learning technique because today's session, I would like to take everything in machine learning applications. So this machine learning technique in general will be classified into supervised classification and unsupervised classification. This supervised classification further classified into classification type of thing and regression type of thing. So many machine learning techniques are developed, something like support vector mechanism, naive bias, GLM, ensemble based methods, and decision tree method, neural network method. So many machine learning techniques are there. In this study, I would like to show a few techniques like boosting type of techniques and classification type of technique, how this technique will be incorporated in our studies. So why machine learning techniques are needed? The machine learning methods have attracted great attention due to the ability to address the nonlinear and complexity in the input and output parameters. In simple sense, how we can explain the machine learning technique means machine learning technique will extract the hidden relationship between the input and output data, because some of the data, some of the relationship will be having multiple linear relationship, but machine learning technique will extract the multi non-linear relationship between the input and output parameter also. So in general, the machine learning data set, we need the number of inputs and one targeted output is required. But basically, the output data set will have maybe a linear relationship or non-linear relationship, sigmoidal relationship, or whatever it might be. All this relationship will be extracted based on the machine learning technique, and we can develop that model. So in this one, we use the random forest method. Random forest method is a ensampling type of regression method. So basically, it will use a decision tree type of classification method. The same random forest method, we can use it for classification as well as the regression type of problem also. The main application of random forest model will be it will reduce the overfitting type of things, and it will bring the better relationship between input and output variables. And similarly, the support vector mechanism or support vector regression technique is very useful in regression type of data set. We can say that it will reduce the main thing is it will reduce the overfitting type of error. And for same technique, we can use it for classification as well as the regression type of thing also. The picture will explain how the hyperplane will segregate the type of clusters or type of variables for the various hyperplane. And similarly, we can use multilinear perceptron. Multilinear perceptron is nothing but it's simple ANN technique. So here, various number of inputs are there, and you can develop a number of hidden layer, and the output may be a single output or multiple output also. So in hidden layer, we have to assign the suitable activation function. Normally, the input data will be normalized, and normalized input will be transferred to the activation function. Activation function will generate the weights, and the modified input signal will be transferred to the output function. Output layer will evaluate the error criteria. Based on that, the signal will be propagated back to the input layer. This process will continue again and again for getting the maximum required output functions. This is also a simple ANN technique, how the signals will be transferred, how the weights will be calculated for each and every nodes. Then we are having the M5 decision tree technique. This is also a simple decision tree type of technique. Then we can use in this study, we use the adapt boost method. So for our model development, we used the adapt boost, exit boost, then gradient boosting classifier, extreme gradient boosting algorithms, and cat boost algorithm, stochastic gradient boosting algorithm. All boosting type of algorithm we tried, along with the logistic regression technique. In logistic regression technique, you cannot say, you can say like this technique is not fully a machine learning technique or not fully a statistical technique. Most of the time, the logistical regression approach will give you better results for the nonlinear relation type of data set. So I don't want to explain too much about the various type of machine learning technique. I will tell you how we can use this machine learning method for various applications. Okay, so in machine learning technique, the overall evaluation metric, we can use it accuracy, sensitivity, specificity, precision, and NVP method. Along with that, we can use AUC and ROC curve for evaluating your model accuracy. So the first case study we used in that model is a comparative study of conceptual and machine learning models for stream flow modeling in the Godavari catchment. So in this study, we used the machine learning technique for generating the future period of stream flow. So the objective of this method is we are using the climate change scenario data set as the input. The output will be the stream flow measured by the CWC. So we are developing the machine learning model to validate the future forecasted stream flow data. For this, we implemented the study in the Paranita subwatershed in the Godavari basin. It's nearly 2,600 square kilometer area. The average annual rainfall is 1,421 mm. It's having a normal rainfall catchment area. So the overall methodology of the study is explained here. The input data will be the IMD gridded precipitation data set. The output data or targeted data will be the stream flow data measured at the Varigar station. So first thing what we have to do now, we have to normalize all the data for feeding into the machine learning model. The data set will be divided into 70% and 30% for training and testing purpose. Here we incorporated SVR technique, that is support vector regression, random forest regression, multilinear perceptron, M5P T-type regression technique, and linear regression technique. So these data sets are normalized and given to the model structure. So the model is evaluated by using the Nash Cutcliffe coefficient and R square and RMSE or model evaluation parameter. So based on this one, the model is giving better accuracy than the conceptual model. the error statistics and the fitting of accuracy is shown in the training and testing data set. You can see here the scatter plot of testing and training parameter results. So this evaluation parameter accuracy also plotted in the Taylor diagram, and here you can see that evaluation parameter results. Actually, some of the results we hide here because some of the results is not yet published, so I didn't shown here. The second case study is flood susceptibility mapping for Chennai Basin using remote sensing technique and machine learning technique. Here, the data, whatever data we prepared by using the GS and remote sensing technique, all this data will be converted into a numerical data set and then fed into the machine learning model. So in this study, we used the flood susceptibility mapping. Normally, we all know what is flood. Flood is nothing but the excess stream flow or natural runoff water overflowing the bankfull storage. Then and subsequently, it is inundating the adjacent area. We will call it as flood. Why we have to model the flood inundation means India is vulnerable for all type of disaster, and frequently our Chennai is affected by flood in a regular manner. Whenever there is a storm surge or whenever there is a cyclonic storm movement towards Chennai, means Chennai will get more amount of precipitation, and subsequently that area will be get inundated. And moreover, it's rapidly urbanized city. The impervious areas are very high, and most of the natural storms and drainages are vanished somewhere, and some of them are not in proper function. So due to this reason, this basin is highly affected by the flood. So the flood is not only in our region, throughout the globe, it is a common phenomena. Last year, from 2022 to 24, if you see, many places the flood is occurred. Even if you see the recent floods happened in Libya, actually it's a cyclonic storm movement. That dry weather, arid country like Greece, Turkey, Libya, all these things are affected by flood. And last year, if you see, Saudi Arabia and Dubai also get affected by severe floods. So for a reason is simply we can say that due to the climate change, the rainfall pattern was completely changed. We can expect even in near future also, we can expect very high intensity rainfall in shorter duration, which will induce the flash flood type of thing. And in India, if you see almost all the metro cities like Mumbai, Bangalore, Hyderabad, Chennai, all are affected by the heavy intensity of storm in a shorter duration. And this will give you a chronological major flood events happened in India. This will tell you how the flood is very big danger for our problem. So in this study, this machine learning technique was incorporated for Chennai Basin. Chennai Basin, if you see, we are having Arani, Kudamurati River, then we are having Kuvam River, then we are having Adayar, and some streams are flowing from south to north in that Palikarnai region. So we are all know that the rainfall wise, we are having more than 1,200 mm rainfall in Chennai region. And the record data set was land use, land cover, rainfall, digital elevation model, geology, geomorphology, and soil. Land use, land cover data, we used the Google Earth engine for preparing the land use, land cover data. Similarly, the rainfall data set, we used CHIPS data set. For that, we used the Google Earth engine. From that, we prepared the average annual rainfall of the Chennai region. Then we downloaded the digital elevation model from the using the SRTM data, 30-meter resolution DEM data. From that, we calculated the topographic wetness index, steam buffer index, topographic ruggedness index, slope, curvature, everything we determined by using the Google Earth Engine code itself. Then we downloaded the geology data from the Bookosh website. So this is a government official website. We used the data. Then for soil, we used the NBSS land use planning data. From that, we prepared the soil map of Chennai Basin, and then we converted into a raster data. We used it. So before implementing a flood model, we have to identify what are the factors or parameters will affect the affect the flood, and what is the relationship between the flood generation capacity and the input parameter. So in this study, we used the elevation, slope, drainage density, distance from river, rainfall, soil, flow accumulation, and the elevation are the parameters. So here in that one, if you see, the elevation is normally a inverse relationship with the flood inundation. Wherever the elevations are more, flood susceptibility or that inundation capacity will be very low. Similarly, slope, if slope value is very high, means the inundation chance will be low. So it will have a inverse relationship. Then drainage density wise, wherever the drainage densities are more, that area, the inundation will be very high, because drainage density is nothing but number of drainages within one particular area. Similarly, distance to river is another one factor. It will have a inverse relationship. If the distance to stream is less, means there is more chance for flood inundation. So if you go away from that river, the chance for inundation will be very low. So the relationship will be inverse relationship. Then rainfall wise, it will have a direct relationship. If the rainfall intensities are more, it will produce more amount of runoff. Then it will create more amount of inundation. Then soil type, soil will have a non-linear relationship actually. Based on the soil type, it will have a relationship with the flood inundation. If the soil is normally a clay soil or sandy, clay loamy soil type of thing, it will produce more amount of flood. If it is a sandy soil, then the amount of flood generation or flood vulnerability will be low. And similarly, the flow accumulation parameter is a direct relationship parameter. If the flow accumulation amount is increasing, means it will bring more amount of water to that particular point. So it will increase the susceptibility of the inundation. Then need for the study wise, before going for any engineering application of flood mitigation or flood rehabilitation works, we have to know which are all the areas are highly vulnerable for flood, and what is the probability of occurrence of the flood in that particular area. We should know. Based on that only, we can develop the remedial measures for that particular location. So the prepared input files you can see here. This is the digital elevation model of the Chennai Basin. So the elevation is ranging from 0 to 1,337 meter. Then this is the slope map derived from the digital elevation model. Slope is nothing but the first order derivation of the digital elevation model. Then we can derive the steam power index map, and we can derive the curvature map. Curvature is nothing but it will tell you whether the flood will be converging toward the particular area or the flood will be dispersed to the adjacent area. Then next we are having the topographic wetness index. Topographic wetness index will tell you the moisture condition of the particular location. If the topographic wetness values are more, means that area will be more wet. So if there is additionally, is there any rainfall is happening in that particular area, means it will induce more amount of flood. In this picture, you can see that wherever the blue color areas are there, that areas are having high vulnerable for flood, because these areas are having more topographic wetness index. It will produce or it will generate more amount of surface runoff in that particular area. The infiltration will be very less in that area. The next parameter is the aspect. Aspect will tell you the directional slope. Based on the directional slope, the convergence of flood will be occurring in one particular area. So the next parameter is the rainfall parameter. Here you can see that dark blue colors are having very high intensity of the rainfall. Here the rainfall variation is 1876 mm to 860 mm rainfall. So wherever the high rain contents are there, it will produce more amount of surface runoff. Virtually, it will affect the flood inundation in that particular area. Then drainage density map. So based on the drainage density, we can understand that. Sorry, actually, it's distance from rain, distance from stream. So based on the distance from stream, we can say that if the distance is low, then it will have a more chance for flooding. Then we are having the flow accumulation map. Here you can see very clearly the three river systems like Arniyare, Kudamurutiyare, Adayare, and Kuvam region. These four rivers you can see clearly. So flow accumulation will bring the water from the furthest extreme point to the watershed outlet. So near to the outlet or near to the section, it will bring more amount of water that will induce more amount of inundation in the downstream area. Then next important parameter is land use land cover data. So this land use land cover data is prepared from the Landsat satellite image. The red color areas are shown. Is there any problem in my audio? I'm getting some warning message. Hello?
No, sir, it is clear.
Oh, okay, thank you. So this red color areas indicate that it is the settlement area in the Chennai region. So if the settlements are more, means the surface imperviousness is more. So the infiltration in that particular area is very less. The remaining areas are agriculture land and barren land. All this area will have more amount of imperviousness. So the runoff generation will be very less in that particular area. So next we are having soil data. In soil data, if you see that most of the areas are falls under the sandy clay type of thing. Some of the coastal states we are having the clay loamy type of soil, and overall it's the dominating soil type is a clay soil type. So the infiltration will be very low and it will produce more amount of surface runoff. Then we took the geomorphology as the parameter. So based on that, we are having alluvial plains and pediplain is the major dominating area, and we are having coastal plain also. This geomorphology will affect the infiltration characteristics of the catchment. So based on that, the surface runoff generation will happen. So normally the alluvial region, the material will be a sandy region. So the infiltration will be more in that particular area. Remaining area, pediplain region, the infiltration is very less. Automatically, it will produce more amount of surface runoff that will lead the inundation in that particular area. So this overall methodology base, if you see here, all these parameters are prepared in the raster format. So all the layers should be in the same projection and same data type and the same pixel size. After preparing all the data, we have to convert this data into a numerical values. That conversion we have to make it, and this numerical value will be given into the ANN model. So this overall data set will be divided into 70-30. 70 is the training data set and 30 is the testing data set. To evaluate the model, the target parameter is the already existing flood location or flood inundation point. For this purpose, we used the SAR data to identify the flood inundation map. So after finding out the flood inundation point, already existing flood inundation point, that point will be used as the targeted values. So we prepare the 750 flood inundation point by using the synthetic aperture radar satellite image, Sentinel-1 satellite image. That data will be used for the target parameter. By using the 12 input parameter and the Sentinel-1 SAR data as the target parameter, we used the random forest method, support vector mechanism, logistic regression model to develop the model. So based on this model development, we got the flood susceptibility results. Here you can see the random forest, support vector mechanism and logistic regression results here. So these red color areas are, if you see that this area, the soil type is clay and the slope is very less. This left upper corner, the slope is more. And the right side, if you see here, this area, the imperviousness amount is high. So the surface runoff generation will be very high in that particular region. So overall, this susceptibility amount is classified in that one. In this study, actually, we developed more than this 3 model, but I shown few results here. The overall accuracy of this model was evaluated by using the ROC AVC curve. If you see this one, random forest and support vector mechanism will give you 0.93 RM AUC value, and the logistic regression giving 0.5. Actually, we used machine learning techniques for many studies, various disaster modeling application like forest fire, landslide, then flood, stream flow modeling. So many problems we tried by using various things. Most of the time, we got very good results for the boosting type of models only. But especially in Chennai region, we got very good results for the logistic regression. This is the best results we got it for the logistic regression. Normally, logistic regression won't give you best results because I already told you it's not a full-fledged machine learning technique or not full-fledged statistical technique. But we got very good results for that logistic regression approach. And we simultaneously tried for other technique like gradient boosting, extreme gradient boosting, support vector machines, and random forest and Navier bias also we tried. In this one, if you see this Navier bias, the results is not so good. It might be the Navier bias technique is purely a probabilistic based approach. It will try to give you the results between 0 to 1, that is flooded or non-flooded type of results. It won't give you the probability of occurrence of in between classes. So this is a very good technique. In fact, very good technique for finding out the initial type of results for going for any engineering type of mitigation work. So the next case study I want to show you a landslide application, how we can use the machine learning technique for landslide modeling. So if you see what is the need for this one means India is highly vulnerable for all type of disaster because our topography and various adjacent features about our geography. We are highly vulnerable for all type of disaster. If you see, especially in the Himalayan region, it's highly vulnerable for earthquake because it's a tectonic region. And if you see, all the glaciers are melting nowadays. Recently, when the Wayanad landslide happened, immediately after 4 or 5 days, there was a very big cloudburst event happened in Himachal Pradesh, and consecutively it will produce the flash flood. It damages 2-3 hydropower plant in that particular river stretch. But this Wayanad issue was highly highlighted. So we didn't give much importance for that cloudburst event. And some of the cloudburst induced floods are increasing in the Himalayan regions, and forest fire also very high in that particular region. Earthquake is very common in Himalayan region. Apart from that, if you see the Western Ghats and northeastern region, we are having very high vulnerable for landslide. Whenever there is a monsoon started, these particular areas are having very high chance for landslides. So in this study, we took that Idiki districts for our study to apply the machine learning technique for landslide modeling. So we are all know very well, in 2018, there was a very big tragic events happened in that Idiki district. Due to that heavy rainfall, you can see number of landslide was happen. Totally in that particular region, if you see this northern portion of the region are highly vulnerable for landslide. Even after 2018, 2020, 22 also, there was many landslide incident happened in that particular region. So in this study, what is the novelty or new things we incorporated in that model development means, normally the landslide studies, people will incorporate the geological, geomorphological, and hydrological parameter as the input, and we will use the already existing landslide location as the target parameter. From that, we will develop the machine learning model. But here we introduced a new input parameter, that is something like land subsidence data as the one input parameter. This land subsidence or land displacement data was derived by using the Sentinel SAR data set. By using this Sentinel SAR data, we find out the interferometry in that particular region. From that, we calculated how the land subsidence is happening in that area, how the land subsidence or land movement will induce the landslide in the particular area. We developed the relationship between this input data and the output targeted values. So the first foremost important step is to develop the interferogram using the SAR input data. So in this model, most of them are not familiar about this one. So I don't want to go into deep for developing the interferogram. So interferogram is nothing but it will look like this. So you can see number of fringes. So wherever the movements are more, it will give you very narrow fringes. Wherever the stable slopes are there or movements are less, it will have a broader range of interferogram. So initially the data will be something look like, because microwave is not a imaging type of remote sensing technique. Normally this type of data will be de-stripped and merged into a single data set. Then we are using the data set for preparing the interferogram by using the phase unwrapping techniques. So this is the overall flow chart for identifying the displacement map or subsidence map. So after preparing the data, you can see these results here. Wherever the red and yellow color are shown here, that area the land displacement or subsidence was very high in that one. For developing this image, we considered the 17th May 2018 data and 21st August 2018 data set. This is nothing but before the event and after the event. So that too will give you how much amount of land displacement was happening in that area. The positive value will indicate the uplift of the land, and negative value shows the subsidence of that thing. After preparing this data set, we will use this layer as a input for the machine learning model. So the problem of creating the land subsidence data is very important. Thing is, it's not a simple procedure. The pre-processing itself will take too much time and too much problem based, because each data set will have 1 GB for one image. If you download, that many number of images are required to make the study area. So the processing also, it will take too much time to do that thing. And this stamps software, initially it was developed by using the Java code. After that, we searched and we find out the MATLAB based code. By using this code only, we can able to prepare the land subsidence maps, because initial algorithm that software was running too slow. After using this code, we can increase the processing speed, and then we find out the persistent scattering and all these things. This picture will show you the location where you are having the stable and unstable location, and the velocity will give you the subsidence value or land movement value. From that, we are actually we carried out the field survey in that Idiki district, and the already existing landslide location as well as the velocity vector map. We map the relationship between wherever the velocity vectors are more or the land movements are more, that area we observed many landslides in that study area. So this overall time series data set will provide you the land subsidence movement in that particular locations. So this is the overall methodology flow structure of the landslide susceptibility model. In that one, if you see the data set, I got some problem. Somebody's mic is on. Hello. Is it okay? Okay. So in this methodology flow chart, if you see here, we classified the data into non-categorical classes and categorical factors as a two separate input. Then we developed the land subsidence map as a separate layer. Then these data sets are converted into numerical data set. This numerical data set will be fed into the machine learning model after dividing 70-30 as a training and testing data set. Here already the existing landslide location are used as the target parameter. So with that, we developed the landslide susceptibility map in that particular area. So if you see this input parameters, we use a digital elevation model, and then slope, then the curvature. Curvature effect is highly important in landslide. If you see, most of the landslide will occur in convex type of region, and in flat terrain, we are having very less amount of chance for landslides. Then topographic wetness index, I already tell you, topographic wetness index will indicate the saturation amount of soil in that particular area. So wherever the topographic index values are more, that areas are having high chance for landslide susceptibility. And steam power index is nothing but it will tell you how much amount of energy is there for the steam to reach that particular area. If more steam power area, steam power values is there, means that area will be highly vulnerable for landslide. Similarly, the topographic ruggedness index. Normally, the topographic ruggedness index values are low, means that areas are more stable. If topographic ruggedness index values are high, means that area may have some critical slope or something. So more vulnerable for landslides. Then steam transport index will tell you how much amount of sediment or water that particular pixel can transport from one particular point to other point. Based on the steam power index values, you can say that if the steam power index is more, that areas are highly vulnerable for landslide. And low steam power index values are having less chance for landslides. The next input parameter is the aspect. Aspect is nothing but the directional slope. If you see the flat terrain areas are having very less chance for landslide. The slope towards south and east or southeast, these slopes are having very less amount of moisture content normally, because most of the time our based on our topography, the sun will illuminate on this slope. So mostly these slopes are comparatively dry in nature. But if you see the slope falling into north or northwest or west direction, it will have more amount of moisture in that region. So even for small amount of rainfall intensity, that area will get saturated quickly, and the slope will turn into a critical slope. And if you see here, based on this map, you can see the rainfall intensity. So the rainfall amount varies from 2,200 mm to 3,700 mm rainfall. In soil type wise, we are having clay soil, loamy soil, and gravelly clay soil. Mostly the district falls in clay type of soil. So geology wise, if you see, most of the areas are having chalconite, and gneiss type of rock is the dominant rock type. And geomorphology wise, we are having highly dissected structural area. So next, if you see that input parameter, we are having distance from road and the distance from stream. I already told you, distance from stream is the inverse relationship with the moisture content. So if you see, most of the landslide will occur near to the streams, and it will propagate towards the upstream side. Some of the landslide will trigger on the upstream side, and it will material will travel towards the downside slopes. So if you disturb the natural slope by cutting that road surface, that area, the slope will turn into critical slope. That areas are highly vulnerable for landslides. So next input parameter is distance from lineaments. So the lineaments are nothing but it's a natural crack on the earth mantle. So it will act as a lubricating surface between these two things. Whenever there is a rainfall, this area will get saturated quickly. Even in this recent Wayanad landslide also, you can see the impact of lineaments in the landslide. So next is land use, land cover. So in that particular area, the natural forest is converted into tea and coffee estate. So that will induce the amount of saturation. So because of the high saturation, the soil mass will try to move towards the downslope side. And then we are having the normalized differential vegetation index and displacement map. So in this normalized vegetation index will tell you how much amount of vegetation content in that particular area. So normally the NDY values are more, means that area will get more saturated. That will induce more amount of landslide. Similarly, if you see this picture, the land subsidence values are very high in that particular area. So land subsidence or land displacement values are more, means it will induce more amount of landslide. The probability of occurrence is more. So this pixel, if you see here, this is the landslide inventory map. In 2018, our NIT team people, myself and my scholar, we visited in that particular area, and we collected nearly 700 landslide points, 700 landslide location. Out of that, we used nearly 500 landslide point for developing this model. So the target parameter is nothing but the landslide inventory points. So here you can see some of the already existing landslide picture. Here, based on this picture, you can identify what is the type of the landslide, how the landslides are occurred. If you see the second picture, you can see there is a stream in between. So most of the landslide will happen adjacent to the stream only, because this area will get saturated very quickly. And if you see the soil type, it's mostly a loamy type of soil. So this picture will show you the landslide location in and around the district. So before developing the model, we have to do the variable influence factor. That means for developing the model, we are considering so many input. Some of the two input may act as similar manner. So in that case, we have to discard one particular input. For that, we will call it as feature elimination process. So for doing the feature elimination process, we use the support vector mechanism as a feature elimination technique, and we removed some of the less influencing factor. Then the remaining factors we considered for the model development. So these are all the highly vulnerable factors for the landslide model. So in this study, we used 20 input parameters and landslide location as the target parameter, nearly 5,990 pixels. Actually, totally we considered 570 points. 570 points, if you converted based on that pixel conversion, we got nearly 6,000 pixel point. Out of this 6,000 point, we classified into 70 and 30% for training and testing data set. We implemented, mostly in this study, we used the boosting type of algorithm. We used ATAL boost, Navier bias, neural network, random forest, support vector mechanism, and the extreme gradient boosting also we used in that study. So these are all the results obtained from the technique. Here, if you see that ATAL boost model, most of the landslides occurring in the northern side slope. This was proved that recent 2020 Rajamala landslide also happened somewhere in this particular region. So these results will validate this northern region in that Idiki districts are highly vulnerable for landslides. So in this random forest also, you can see that results. This XGBoost will show the similar type of results with a different intensity. It also shows that the northern side of that study area is highly vulnerable for landslide. Remaining areas are somewhat stable. And neural network model predict most of these areas are highly vulnerable. Middle as well as the northern regions are highly vulnerable for landslides. And similarly, if you see support vector mechanism and Navier bias are not very good or very well predict the landslide vulnerability in that area. It shows a little bit aggressive only compared to other models. So the overall statistical classifications are shown in this picture. So here you can see the ROC values, sensitivity and specificity value for all the six models. So in that ways, the ADA boost and random forest XGBoost are giving better results than the Navier Bayes model. Always the Navier Bayes model and logistic regression models will give you not so good results because both are somewhat a statistical based technique. So this ROC results, you can see this one, random forest, ADA boost and XG boost will give you better prediction accuracy. The statistical values of that results is shown here. And area wise also, various classes of area for this six model you can see here. So this advantage of this model is incorporating the land subsidence layer as the input parameter. This is a novel approach compared with the other ML based landslide model. Mostly they will use either geology geomorphological input as well as the hydrological input. But this in this study we used the land subsidence results for developing the landslide vulnerability model. So limitation of that study means the only limitation is the data processing only. So preparing the interferogram is very difficult task. Difficult task in the sense we need more computing facilities. The RAM, at least 32 GB RAM is required for doing the processing. And each and every data I already told you, one single image will have 4 TB in size. So it's very difficult to manage with a normal laptop. Cannot use the laptop for doing the processing. At least we need some server type of machines for doing the process. So next case study I would like to show is the machine learning based forest fire vulnerability susceptibility mapping for the Western Ghats region. So last few days we are knowing that story from US that California and western part of that country is severely affected by the forest fire. And based on the video and picture, we can understand that how much severity or how much vulnerable for that forest fire in that particular area. Even they are having very good sophisticated technique, very good developed mechanism, satellites, very well developed road network, and so many modern techniques are having. Even though this disaster wise, they cannot manage very well. That means we can mitigate some of the natural hazards, but we cannot avoid the natural hazards. So in that ways, this forest fire study, we are having some 4 different type of forest fire. One is surface fire that will propagate on the ground only. Creeping fire type of thing, it will move very slowly and intensity also very less. Then ground fire will burn in the bushes and other thing. Then the next dangerous one is the ground fire. Ground fire will be very dangerous. It will burn in very height. It will burn in the trees canopy also. So normally the reason for wildfire disasters are accident, deliberate causes, and natural causes. Natural causes means whenever there is a very dry or arid condition occurs, that time there is more chance for getting the forest fire. Or sometime due to the summer shower time, the thunderstorms or the flashes will induce the forest fire in that area. Normally, the bamboo forest, because of the friction of canopy, it will induce the forest fire. But most of the forest fires are happen due to human intrusion. So this will give you a overall synoptic view of forest fire throughout the globe. So this picture will tell you the hydroclimatic region of our country. So the forest cover region, we are having mostly the Western Ghats. Then we are having very high density forest in Chhattisgarh, Orissa, and the Jharkhand region. Then Northeast and Himalaya, we are having very thick forest fire region. But if you see the western part of the Western Ghats and the forest in Chhattisgarh and the Jharkhand region, mostly these forests are open forest type, not a very dense forest. We can have a dense forest in the southern part of the Western Ghats and the northeastern region and Himalayan regions only. So whenever there is a open forest is there, means especially in summer time, it won't have any leaves. That it will discard the leaves and it will produce huge amount of litter in that particular area. So whenever there is a small amount of fire triggered in that area, that will propagate this area severely, and the intensity of the fire incident will be also very high in that area. If you see this fire existing point, actually this fire point was measured from the Modi satellite. Based on that, the fire pixel locations are shown here. So if you see here, most of the forest fire happen in the northern part of the Kerala or southern part of the Karnataka, and a lot of forest fire happen in that Odisha, Jharkhand, Chhattisgarh region. And you can see number of fire pixels in northern region. The northeastern state, the number of fire incident is not due to natural incident. It is because of that local people, they are burning the forest, and because of the shifting type of cultivation thing, these areas are having high vulnerable for the forest fire incident. So based on the satellite image, if you see here, these regions are having very high vulnerable for the forest fire. The red color area shows maximum amount of forest fire. And this table will tell you when it will have maximum chance for forest fire. If you see, the most of the forest fire happen between February to June. That time throughout the country is hot summer weather, and the moist level in the air or soil will be very low. So most of the fire incident happen between February to June. Remaining period, due to the monsoon, the number of incident was very less. Even last year, 2024, Uttarakhand region, there was a very big forest fire. Government also faced a lot of difficulties to control that flood. Finally, the army was implemented in that particular area to minimize the fire progress, because it's moving towards the upper reaches. So this will give you the overall statistics of each and every district, how many number of fire incident happen. So in this picture, if you see Odisha, Mizoram, Madhya Pradesh, Maharashtra, Chhattisgarh, these regions are having more amount of forest fire, because the forest in that particular area is a dry forest, open type of forest. So it will have more amount of fire incident. This picture will tell you the fire frequency between 2004 to 2017, and monthly base, each month, how many number of fire incident happen, that will shown in this picture. So by seeing this picture, we can understand that the maximum number of fire incident happen in the month of April. So this will tell you the various number of fire incident and the burnt area for the different geographical location of our country. So I want to skip some of the statistics here. So this is the type of forest. This one, what is it? Before and after incident happened in that same region. So normally, whenever there is a monsoon time, we are having a lot of bushes along with the thick canopy. But in summer time, these bushes will become more dry. This area become dry. That will propagate more amount of fire in that particular region. So in high altitude, if you see, you can see this type of dry grass type of things. Normally, we will call it as a boogial region or grasslands or shola forest, we will say. So this area, the chance for getting forest fire is very high. And so the satellite data involved in mapping the forest fire is MODIS data. We are having 4 MODIS bands for measuring the forest fire incident. So normally the data will be available from 252,000 meter resolution. So this forest fire MODIS data is used as a target parameter for finding out the forest fire vulnerability. So in this study, what we done is we developed a forest fire vulnerability for the Western Ghats region by using the conventional weather parameter and a topographic parameter. Then we we further developed the model for future vulnerability of forest fire due to climate change, because the input parameters involved in this study is precipitation, temperature, and wind velocity. Due to climate change, the wind velocity and temperature is changing, and precipitation also will have a lot of changes in the future climate change. So how the climate change will affect the forest fire vulnerability in that Western Ghats region, that also studied in that study. So the study area we took from the entire stretch of Western Ghats. The total area of the Western Ghats study region is 56,312 square kilometer. That much forest area is covered in that Western Ghats study region. The overall it is 1,60,000 square kilometer region. It contains Kerala, Karnataka, Goa, and part of Maharashtra also. So the data set used in this study is landslide 8. Data set is used for preparing the land use land cover data, normalized differential water index data, normalized differential building index data. So this optical 30-meter landslide data is used for this purpose. Then similarly, we used Landsat 7 and Landsat 8 TARS data, because these two data sets are having the thermal bands. So that thermal band is used to find out the LST in that particular region. LST is nothing but land surface temperature. Then SRTM data is used for preparing the elevation, slope, aspect, and topographic wetness index parameter. Then the Google Earth engine was used to find out the distance from road, distance from stream, distance from the village, and distance from settlement. All these parameter we used the Google Earth engine. And NASA firm data is giving the fire incident point directly by processing the MODIS data. There is no need to process by ourselves. The ready-made data set is available with a 375-meter resolution, and 1 kilometer resolution also is available. By using this, we can develop our own model. Then IMD gridded data is available free of cost. So by using this IMD data, we can prepare the spatial variation of temperature, rainfall, and wind speed. So in this study, this is the long-term average fire incident points happen in the Western Ghats region. So this MODIS data is converted into 30 meter by 30 meter pixels. So nearly we got 3000 pixels, and then we divided into 70-30 for developing the model. Then we prepare the input data like digital elevation model. From that, we prepare the slope of that study area. Then we develop the aspect from the digital elevation model. Then curvature also derived from the digital elevation model. Here, the slope will tell you if the slope is very steep, the progression of fire will be very less, or if the slope is gradual or rolling slope, the fire movement will be very high in that particular area. Similarly, the aspect will tell you the amount of moisture or wetness in that particular slope. So normally the slope exposed to the suns are having more dryness. That area, the progression of fire or occurrence of fire will be very high in that area. Then based on the convex and concave region or flat terrain, the intensity or movement of fire will be different. Similarly, the topographic wetness index will tell you the amount of moisture presence in the soil. So if the topographic wetness index are low, means that particular area, the aridity will be very high. That area will have more chance for getting the fire incident. And similarly, the NDY will tell you the amount of vegetation presence in that particular area. Normally, the more amount of vegetation will give you more fuel for the forest fire. So that forest fire incident and the progression will be very high if the NDVA values are more. Similarly, the land use land cover and land use progress in the Western Ghats are shown here. Normally, the scrub forest or open forest or dry bare forest, thorn forest type of thing will have more vulnerability for the forest fire in that particular area. So similarly, the rainfall variation is shown in that region. So normally the high rainfall region will have less amount of forest fire because the soil and the vegetative content in that particular area will be very high. So the chance for occurring forest fire will be very low in that particular area. Then we are having the long-term average maximum temperature and long-term average minimum temperature variation also shown here. So the temperature is one of the main reason for the forest fire incident. If the temperature variation is more, the dryness will be more in that particular area. Chance for vulnerability will be very high. Similarly, the mean wind speed data is shown here. Even in the California incident also, wind velocity is the major problem. Because of the heavy wind speed, the government cannot control the forest fire movement in that particular area. So wind velocity is one of the very dangerous parameter in developing the forest fire vulnerability map. Then distance from road is a anthropogenic factor. Normally, the most of the fire incident happen along the adjacent to the road only, because it's most of the fires are induced by the human being. Then distance from stream will tell you how much amount of wetness presence in that particular area, how much amount of moisture present in the soil. So normally the adjacent to the stream, the wetness values or moisture value will be very high. If you go away from the stream, the dryness will be very high. So normally the fire will happen far away from the stream location only. Then next is the chance for fire susceptibility from the distance from settlement. So normally the distance from settlement factor wise, the fire vulnerability will be very high near to the urban cluster or village area. It's far away from that location, means the probability will be very low. Similarly, we prepare the soil map and fire pixel point also. Soil layer will tell you how much amount of moisture can hold by the soil. If the soil is sandy loamy soil, means in the summer it will dry very quickly. And similarly, the soil is a clay type of soil or peat type of soil it will hold more amount of moisture, so the dryness will be very low in that particular area. The vulnerability of fire will be low in that particular section. So this factor will relate the target parameter as well as the probability of occurrence parameter. So after preparing all this data, the data are converted into numerical data. Then the first step we have to do the multicollinearity test and variable in a inflation test. Based on these two steps, we can identify which parameters are more vulnerable for more dominating parameter and which one is having high influence with the model output. So based on that, the rainfall, wind, digital elevation model, maximum temperature, NDVA, slope, topographic wetness index, all are having a very high influence on the forest fire thing. Then distance from village, distance from road, land use, distance from stream aspects, topographic wetness index are very low influence on the parameter. But in this study, we took all the parameters for the model development. So here also we developed the forest fire for the entire 12 machine learning models. Though this is the forest fire vulnerability results. If you see these results, the maximum fire points happen in the southern part of the Maharashtra and northern part of the Karnataka. This we can validate it from our fire pixel point also. In this study, you can see maximum number of fire points are happen in that particular area. So these results is well predicted with the model results. In this study also, the logistic regression is giving better results compared to other model. And in this results also, if you see here, the Mudumalai forest region and the southern part of the Karnataka region is having very high forest fire vulnerability. So actually, this work was not yet published, so I didn't shown all the results. I see only two of the results here, two model results, logistic regression and random forest results only I shown here. And how to implement the climate change in this model means these three climate parameters are highly influencing the forest fire vulnerability, that is precipitation, maximum temperature, minimum temperature, and wind velocity. So by using the CMIP6 climate change data, especially the EC Earth 3 wedge model, because we already done the climate change model studies by using 13 climate change model data. So out of that, we find out EC Earth 3 and the EC Earth 3 wedge models are more suitable for various application in India. So we consider the EC Earth 3 wedge model as the input model parameter. From that, we find out the extracted the various climatic parameters for near future, middle future, and far future. This is nothing but the duration between the model development. So the simulated data are available from 2020 to 2100. So you can develop the model for these three time steps for by using this maximum precipitation, temperature parameter, and wind velocity. So from that, we can identify the future probabilistic fire points in that particular area. So here we considered all SSP scenario. We prepare all the data for SSP 1.26, 2.45, and 5.85. All the scenario we prepare the minimum temperature, maximum temperature, and precipitation. In this picture, you can see the various input data prepared for various climatic scenario. So overall, this scenario, we identify the spatial variation of all these parameters. From that, you can identify or you can predict the future vulnerable region of forest fire using various climate change scenarios. Okay, that's it from my side. I want to stop my presentation here. I want to interact with you. If you have any question, queries or doubt, you can ask me. I'm ready to answer. Dear participants, hello.
Thank you, sir. Thank you for your wonderful session.
Thank you, ma'am. Is there any questions I can ready to answer?
Participants, if you have any queries, you can raise. So there is a question in the chat box, sir.
Uh, can somebody read that? Question.
Yes, sir. Apart from forest fire, all other we got data through ArcGIS, right? Is there any difference between an ML model and GIS?
Actually, ML model is a technique. Okay, you can use any type of data for the ML model. This remote sensing technique or GIS technique are used to prepare the data set. Okay, in this forest fire, Moody's data is directly available as a target parameter. Whatever the Moody's fire pixel points are there, that will be used as a target values. Similarly, for your landslide data set also, you can map the existing landslide scar. From that, you can generate the what is that landslide scar map. But it's a little bit tedious. That's why we are going for the field study, and we are identifying the existing landslide location. From that, we are preparing the target point. Like that, even in flood inundation mapping study also, already existing flood points data, if you are having, then you can use that as a target parameter. Or otherwise, by using the Sentinel SAR data, you can identify the flood points. From that, you can use the flood point as a target parameter for your study. So, in all the method, the approach, algorithm, everything is same. Machine learning will take number of input and its required one output parameter as a target. So how we are preparing the target parameter, that is the important part in the machine learning. Remaining part will be machine learning will read the numerical data. So you have to convert the GIS based data or remote sensing based data into a numerical data. That conversion part, actually I didn't explain here. There is a set of codes available for conversion of GIS data into a numerical data. That converted data will be read by the machine learning code, and it will prepare the various machine learning model. From that, you will get the output results. I hope you understand what I explained. If you have any further clarification required, also I can explain.
Thank you, sir. There is one more question.
Yes, ma'am.
Is it possible to do the same analysis for earthquake also?
Definitely. The same technique. It's almost similar to our landslide model study only. Already existing landslide location will be used as a target parameter. Then remaining geological, geomorphological parameter will be considered as an input. By using these two, we can develop the earthquake vulnerability model for any region. For earthquake, we need distance from the epicenter, lineaments, soil type, then elevation, slope, geology, rock type. All these things are basic input for developing the landslide, earthquake vulnerability model. The target parameter is the earthquake intensity or earthquake locations. So from that, we can develop the earthquake vulnerability model.
Thank you for your clarification, sir.
Thank you, ma'am. Thank you for the opportunity. I would like to say thanks for all the participants and the organizer. Thank you all.
Thank you, sir. Shall we
Thank
end
you.
the session, sir?
Yes, ma'am. Yes,
Yes,
thank
yes, sir. Thank you, sir. So dear participants, you can join tomorrow by 6 o'clock through this link. Thank you.
Thank you, ma'am.
6 p.m. or 6? 6